Okay, our weekly updates. Again, we have a lot of updates. Well, this is me. This never changes. This is HuggingFace Leaderboard. I looked at the top. It's still the same. I haven't updated this page. There may be some minor changes, but it doesn't matter. So maybe I told it last time, but there are some changes in the harness, how they do the testing. It was only 4 tests, now it is 7 tests, and the average now is smaller than before. It's not backward compatible. And because of that, models have reshuffled a little bit. So on the first place, we have this model from China. It's called Yi. 34 billion parameters. There is another one for 6 billion parameters, and they are coming from China. And I want to say a few words about this. So this is this person, Kai-Fu Lee. So he graduated from Columbia University and then Carnegie Mellon University. He worked at Apple, SGI, Microsoft, Google, was former president of Google China. And by the way, most of these positions were executive positions. And he created, became CEO of Sinovation Ventures. It's more than 2 billion investment fund. And in March, he created a startup called 01.ai, very easy to remember. It's already valued at more than $1 billion. It has more than 100 employees. And the first thing they did, they put these 2 models on Hugging Face. They are open source. You can go there, you can look at Python code, you can actually see what this model does, how it's working. Very, very exciting that this model is only 34 billion parameters, but it behaves better than the best Llama-based 70 billion parameters or Falcon-based, which is almost 180 billion parameters. So it's really amazing. The trend, as usual, we're getting smaller models behaving better than, with more accuracy than more complex huge models. Miscellaneous updates. Well, Amazon apparently training a model called Olympus to rival OpenAI. Well, not released yet. Samsung training Gauss. This is for the mobile platform. Salesforce is putting a lot of effort, and AI have negotiated legal contract without human involved for first time in history. And this picture is, again, it's a joke, but this is true. So this is the first AI CEO. It's a company, Dictador, a Polish alcohol beverage company. YouTube testing generative AI features, conversational tool for asking questions about the content. PixArt, very interesting. So this is a diffusion model, but it's transformer based. Usually diffusion models are based on UNet, which is a kind of convolutional type network developed for segmentation, for recognizing, let's say, well, it was developed for medical purposes to recognize the cell boundaries. But anyway, apparently with transformers, you can get model which is smaller and better. RAG advanced techniques, small to big retrieval. So this is a link to a very interesting, very good article. If you want to do RAG, it's a good reading. NeurIPS or NeurIPS. As usual, in December, there is a huge conference. I will talk about it a little bit later. It was going every year, and it's now 37th conference of Neural Information Processing Systems. You see NeurIPS. Well, but they renamed it as NeurIPS or whatever. Okay, fastest way to serve LLMs. So this is an interesting development. OpenAI and Google are locked into fierce battle for AI talent. So they try to seduce, like for example, OpenAI opens 5 to 10 million per year, mostly in stock or one time, whatever, to seduce people to switch the ship. And they even increase salaries for smaller, for junior employees as well. So it's a very competitive arena in the AI between these companies. But this is only for people who work on these large language models, of course. Google SGA search generative experience. You know, when you go to Google and you enter your query, now they have this feature which they give you something like ChatGPT, and they increasing and updating it, making it better. Now, ROCm, Radeon Open Compute Platform. So this is interesting. So this is a platform which allows you to run CUDA. So it's a PyTorch and CUDA on AMD GPUs, right? Usually, how people work, they use Linux and they use NVIDIA GPUs. This is standard. But now, with this software, which was just upgraded and behaves nicely, you can buy latest cards from AMD. Not all of them, there is a latest architecture called Radeon architecture 3, right? And there are two particular cards. One is Radeon Pro W7900. It's 48 gigabytes, but it costs like $2,500. And then there is Radeon RX 7900 XTX, which is 24, which is similar to NVIDIA 3090, but it costs a little bit less and it's a little bit faster. And you can buy it new, you can buy it used, like for $700 on eBay. Anyway, it's a new world, so NVIDIA loses its monopoly. And what this library allows you to do, it's kind of a glue between your Python CUDA code and this AMD hardware. Okay, by the way, there is a TinyBox. There is a company called TinyGrad, and they develop a TinyBox. So this is like a regular desktop, but inside they put this AMD RX 7900 XTX cards, and they put 6 of them. So the total cost of the computer is $15K, which is very low if you look at how well it performs, like number of operations per second and so on. Another announcement that NVIDIA discontinues the 40, 70, 80, and 90, so they are not manufactured any longer. And it looks like they also canceled 4090 Ti, which was supposed to be released in the beginning of next year. Instead, they will be selling overclocked version of this 4070, 4080, which are not as good as the original 4090. So what you will see that 4090 price climbing up because there is shortage of them. Textbooks are all you need. So this is a very important publication from Microsoft Research. And the idea is that if you prepare data which is textbook quality, right, then you can train small models to be of high quality. So data is always the king, and this article explains how you can prepare this data. So this is really, really important. Anyway, we're now with the Dima trying to work to fine-tune the models, and what we found that quality of the data is everything. Fine-tuning Llama 2 and Mistral Beginner's Guide to Fine-Tuning State-of-the-Art LLMs with QLoRa. So this is a nice Medium article. React Prompt Engineering, Reason plus Act. So it uses 2 agents. This approach is not new. Like, for example, in reinforcement learning, there is an actor and critic architecture. So, or let's say GANs, you have again 2 networks. So here we have 2 agents, and working together, they make the model better. So very interesting publication. Well, Meta, Facebook, released EMU video and EMU edit. So it's not open source yet, but so far they were always eventually outsourcing their stuff. So there are some good links, and if you are into images, this is definitely something to look at. So what you can do, you can edit image, like specifically how you want to change it. Microsoft had a several days event called Ignite, and they announced their own chips, which they will start using next year. So this is Maya 100 or M100, also called Athena, and this is a GPU, and they also have CPU called Cobalt 100 with 128 cores. So this is, they already have like servers running this in test mode. So they will scale this. Analogical prompting. So this is coming from DeepMind, and this is really very, very good publication. So you asking question, but if before the question you give instruction like recall relevant problems and solutions, and then solve the initial problem. So if you formulate in your prompt, like do it, answer it in 2 steps, then the result is much better if you simply ask the question. So it's really like, this is great article, so please read it. Okay, PixArt, a text to image. So I mentioned this before. So this is a transformer-based diffusion model. And you see what's interesting. So these are different models. So here you have DALI 2 or whatever. And here at the very beginning, you have this PixArt A. So you see this is the training time and this is data usage. It's tiny. It's very small. It has less than 1 billion parameters. It takes 10 times less time. It takes like 10 times less money to train it. I mean, it's really, really amazing. Here it is on the bottom of this table, on the right bottom. So you see number of parameters, 12 billion, 5, whatever, and this is 0.6 billion. And yeah, it's quite amazing. And amount of data you need to train it is also smaller. So this is examples of what it can produce very easily. Amazing achievement with a small model, great quality, fast training, cheap, amazing. Great data set, better, smaller, cheaper model. I mentioned it several times. So this is creating an instruction data set to train an LLM. On many models, you will see the word instruct. Instruct means it was trained with instruct dataset. Instruct dataset means that each data point consists of 2 parts, question and answer, or input and output. It's kind of like supervised learning. And so the steps are quite obvious, standard. If you want to create the data set, so you clean and pre-process, categorize sentences, create instruction pairs, prompt answer, ensure a variety of prompts, quality checks, test run, synthetic data generation to fill the gaps if necessary, check for copyright and privacy, check for bias and fairness. So this is very generic list of steps you need to go through to create a data set. And once you have the data set, you can use it for training. So this is just standard steps. You format the data to whatever your training protocol requires. You do train validation split. You select the model you want to use. You tune hyperparameters, try several times, evaluate the performance, iterative improvement. Okay. OpenAI GPTs. So this is a toy, really. So you go into like I have OpenAI GPT Plus, and there is an option there to go to my GPTs, and there is something like a wizard sequence. It asks you questions, you answer it, eventually you create it creates a GPT for you. It's not programmable, it's really a toy. If you want to do something serious, you need to use another feature they introduced, which is called AI assistance. And this is API, which you can call from your Python program. And yeah, you can make like a customer service chatbot or sales chatbot or whatever using OpenAI API like for assistance. Okay, but I'm not talking about them here. Okay, Ultra, foundation models for knowledge graph reasoning. So there are a lot of publications recently about using graphs, knowledge graphs representation, and using them in conjunction with large language models. So here they create a foundation model, language and vision, whatever. I will not go deep into this because I frankly don't understand this. Okay, X.ai announced Grok, right? It's not open for public yet, but they announced it. So Igor Babushkin, who is leading the project, so to create the Grok, we built a custom training and inference stack based on Kubernetes, Rust, and JAX. Well, JAX, understandable. JAX is created at Google. It's kind of Google's version of PyTorch. Just after execution, library developed by DeepMind, Google, and Igor Babushkin is coming from DeepMind, if I'm not mistaken. So it's Rust-based, scalable, reliable, maintainable infrastructure. So we see Rust is gaining more and more territory, and this is the whole system is built in Rust. So this is example of simple Python code with using JAX. Suddenly I'm confused because I thought JAX is for Python, but maybe it's also callable from Rust. Anyway, these are some models, and this is Grok 1, which was released, and they are sorted by their performance. So you see that it's, well, quite respectable positioning. Next is HelixNet. So it is actor, critic, and regeneration, a deep learning architecture consisting of 3 LLMs. Remember, I spoke about actor, critic in reinforcement learning, 2 models. Here there are 3 models, and they iteratively improve their response. So the actor produces initial response, critic takes input tuple system context question and provides critic based on provided answer, blah, 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 and finally they regenerate it and continue. Okay, local chat using Ollama and Gradio. I really like this presentation because he explains how easy it is to create an app with visual interface using those tools. And this is open source, you can use everything here. Okay, weights and biases. Weights and biases is a platform that is used by everybody. So when you are running training, you can, here you're running training. So first you install the module called 1DB, weight and biases, and then you log in. So it's online, but it's mostly free. And then you initialize it with the name of your project and some configuration. And then as you train the model in a loop, you do logging, 1db.log, and you provide a dictionary of what you're logging. And then at the end, you do finish. And if you, when you start your training, it will give you a custom URL. You go to this URL and you see those graphs. You see like how it's training, how the error decreases, and so on. So they allow unlimited experiments for free, unlimited tracked hours, and they up to 100 gigabytes storage and artifacts tracking. So for all real purposes, it's all completely free, although they do have an enterprise version and they charge $35 per month per user. So it's also a possibility. So it's a very good service. Model files. If you look at the model files on HuggingFace, like for example, this is the Mistral model, the standard model, you will see 2 big files, 9 gigabytes and like about 5 gigabytes, and they're called 1 out of 2 and 2 out of 2. And there are some other smaller files, JSON files, configuration files. So if you take this model and you just do torch load and you look inside, you will see that inside is just a dictionary. So this file is a compressed, I think they use Pickle when they saved it. It's a binary file, but when you load it in Python in Torch, you will see it's just a dictionary where keys are whatever, like for example, it's some sort of layer and then name of the matrix, and the values will be the matrices, the tensors. So these model files, they contain all the weights of the model. So it's but it doesn't explain how to use those matrices. And for this, what you do, you go, well, in my case, this is on my computer. If I go to my Python, miniconda lib, and then I go to my specific Python, site packages, transformers, and models, there are right now 225 directories. So if I go to directory Llama, for example, or I go to directory Mistral, I see some configuration files, and I see a file called modeling Llama or modeling Mistral. And if you go into this file, you will see the code which explain how to use this model and configuration to actually run the model, how to train it, how to do the inference. It's all in this file. It's all open source. It's all on your computer if you install the Transformers package. As models are being added to HuggingFace, they periodically update, and the number of directories grow like very fast. Every several weeks, the number of these directories grow. So to use the model, you need this and you need this. Well, you can also probably use the model without Transformers model. You can just use a plain PyTorch to run it. But mostly people use this because it's just so convenient. PyTorch tutorials. So PyTorch is a machine learning framework introduced in 2016 by Facebook, right? Its basic structure is tensor. It's like a NumPy array, but tensor can store gradient information so that they can do backpropagation. Just a reminder, when you train the deep learning network, you do a forward pass, and as you do forward pass, you can remember all the how to say all the how each node on previous layer influence node on the next layer. You can think about it as like partial derivative of something. So as gradients, you store this information, and then when you do backpropagation to correct the weights, you use this stored information. It also called autograd or autogradients. And PyTorch is basically NumPy, but also it can store those autograd information. So there are some good courses. So this is PyTorch crash course on YouTube. This is a basic tutorial on GitHub, which I put together, and there's another thing on my as well. RAG best practices. Well, we spoke about RAG, which is retrieval augmented generation, a lot, and these are some good publications, and how to do the re-ranking. Again, I will not go deep into this, but here's an interesting approach. You don't store original data as is in your vector database. What you do instead, you pre-process it. So for example, you can use a large language model to ask it to make a summarization, and then you make vector from this summarization, and then when you do the similarity search, vector similarity search, you can go against those summarization vectors, and this may improve the accuracy of the search. Okay. DeepMind effective prompt seeds. This is very interesting article and description, but the idea is that you can improve the accuracy of the response if you prepend your question with something, and they provide several examples. So for example, they add this. So this is what they prepend to the question. So original prompt was, find the linear regression that describes this data. And now they prepend this. A little bit of arithmetic and logical approach will help us quickly arrive to the solution of the problem. And then the original question, find the linear regression that describes the data. And this prompt works much better than just the original question. And here is another example. Analyze the given information, break down the problem into manageable steps, apply suitable mathematical operations, and provide clear, accurate, and concise solution, ensuring precise rounding if necessary. Consider all variables and carefully consider the problem's context for efficient solution. So this is something you prepend to your question. And amazingly, it makes the response much better and much more accurate. Now switching gears to some events. So this is information about NeurIPS, the conference, Neural Information Processing Systems. So these three people were the ones who, created it 37 years ago. Ed Posner, Caltech, Yasser Abu Mustafa, Caltech, and James Bohr, Caltech. Ed Posner was the main person. Unfortunately, he died many years ago. He got into an accident. I think he was riding a bike and collision with the truck or something. But anyway, for the first 13, 14 years, it was in Denver, then it was in different locations. Last 2 years, it's in New Orleans. So this is this huge convention center. And these are some links which you can follow and learn more. It's always in December. Okay, these are some conferences. I haven't updated. This is several years old, but these are some famous conferences. Anyway, if you're interested, look at this. Kagle, some people don't know what Kagle is. So Kagle is a huge deal. It's a website, it's a company, and it was acquired by Google in 2017. It had more than 1 million registered users. I don't know how many right now. What they do Kaggle competitions. They provide collaborative environment where people can run their notebooks, and you can post there your data set and ask people to create a model, and people compete who will create the better model. Some of these contests are free, some of them are paid, maybe tens of thousands of dollars, and you can win, although it's getting more and more difficult because of the competition. So there was a famous Netflix competition in 2009. It was before Kaggle, right? Netflix provided a training data set with 100 million ratings, whatever, and it was won, and the prize was $1 million. But I think it was like more prototype for Kaggle because it was before Kaggle. Okay, HuggingFace, another famous website. I spoke about it. I talk about them every single week. It's here in New York. Most important advancements in deep learning and AI over the last 30 years. I asked, I think, Bard to make a list and then ask again to add some other stuff, because it mostly provided information about convolutional neural networks, but not about GANs and diffusions. But this is the list. Backpropagation, convolutional, which is Geoffrey Hinton, and convolutional neural networks, which is Jan LeCun, LSTM, which is Jürgen Schmidhuber, which is amazing guy, by the way. He has many good videos on YouTube. HelixNet, so this is in Geoffrey Hinton's laboratory, and what Alex Krichevsky did is using GPU. He basically reproduced the LeNet, the Jan LeCun's network, using GPU, and this created this avalanche of other models. GoogleNet has a lot of authors, and they were improving image recognition classification. And then attention transformers 2016-17. What's amazing is that Google has such a advantage, and then PyTorch took over. GAN, so this is in Montreal. This is Jan Goodfellow and Joshua Benjo, this group, and diffusion models in 2020. So these are some people, like when I start thinking like who immediately comes to mind, like people you have to know, must to know, follow them everywhere. But there are much more, and I can provide more pages. There are literally thousands and thousands of people. Anyway, Rust language for AI. Rust is being used more and more. Like X.ai, I mentioned earlier, they're using Rust as their main technology. Microsoft investing tens of millions of dollars building development tools for AI in Rust. Linux kernel, now parts of it already in Rust, in the latest kernels, and so Rust is getting there. OpenAI uses Rust in so many different places. Anthropic is using, but what's interesting, they're mostly using Rust in their infrastructure, in their data pipelines, somewhere where they need scale and speed and reliability. Meta uses Rust as a server-side programming language. Google is using JAX. So JAX is instead of TensorFlow. TensorFlow is gone. They created TensorFlow, they updated it, they put Keras in front of it, and eventually they decided to basically remove it. There are still a lot of legacy code in TensorFlow, but all the new development is done in JAX. 01.ai, remember the Chinese company? They're using PyTorch. Mistral is using PyTorch. JAX versus PyTorch. So here is import torch CUDA, and device CUDA 0, and whatever. So you're working with torch and CUDA. Here you can use TPU. So in PyTorch you can also use Google tensor processing units or whatever hardware you can. And this is JAX. So you import NumPy, but then you import JAX NumPy. And what it does, it gives you NumPy which can work on top of GPU or on top of TPU. And this is the syntax how you define the device, whether it's GPU or TPU, and then how you work. You see, you say put this array, put this NumPy array, put it on, let's say, GPU or TPU, and then you can do operations, work on it, and all these operations will be done on this accelerated device. Okay, what we see as a trend is using multiple agents. So the hope is if you get many agents working together, somehow you'll get a genius model. And I don't think it's actually working. You can definitely make the model a little bit better by using 2-3 agents cooperating, but like you cannot make Elon Musk out of herd of dogs. Okay, this is it for today. Thank you.